seconds to increment. And the whole game is 60 seconds. Now my friend Arwa Muhammad will continue with you.
When the LEDs are turned on, you have 1.5 seconds to react. In the first half, if you press the button, the score will be incremented by 200. And in the second half, if you press the button, the score will be incremented by 100. In the last half, the score will be incremented by 50. Otherwise, your LED will turn off and another LED will be turned on, and you will get 0 scores. And if both players are equal in the score, their LEDs will be turned on. And when the player wins, his LEDs will be turned on one by one at the end of the game. Thank you.
Okay, my name is Yumna. I'm gonna talk about the main module. The main module is called Whack-A-Mole. It takes as an input the clock and the button signals, and it outputs the player 1 LEDs, player 2 LEDs, player 1 scores, player 2 score, and the countdown timer. The clock generator generates a 1 Hz clock. It's then used in the countdown timer. After that, we have the delay generator and the position generator. The delay generator randomizes the delay between the LEDs, and the position generator randomizes the position of the LEDs. These are then used in the player module, which my colleague will talk about in details.
Hey there, I'm Mohamed Mahi, MIT student here in GUC, and I'm here to talk about the player module here in the Whack-A-Mole project. At first, it takes as an input a 50 MHz clock, the buttons that the initial module takes, and both the LEDs, and it outputs the LEDs and the score. It has 4 states. In the first state, it initializes the score with 0, and it has your preset values for position and for the delay. It then jumps into state 1. In state 1, we decrement the delay each time, and we check if it's 0 or if it's not. If it's not 0, we check if the position, next position that we're going to light the LED in is actually taken by the other player. If so, we try to change it and fix it so it's another position, and then we keep decrementing. If the decrementing ends, we just clear the next position register, and we move its value into the next player register, and we start timeout for 1.5 seconds. Then we move into state 2. In state 2, we keep decrementing that timeout, and we keep checking each time if either the timeout ends or if the button is pressed. If the button is pressed, we clear the LED, and we increment the score depending on when the button was pressed. If it was pressed in the first half second, it will be incremented by 200 points. In the second half second, it will be incremented by 100, and 50 by in the last half second. Timeout counter reaches 0, which means that the button was not pressed in allotted time. It will just skip to state 3. The same case as if the button was pressed. In state 3, it tries to get a random position again in random delay, and it goes into the next position register. And then it goes back to state 1 where it decrements the delay, so it shows the other position again.
After that, the scores is converted into 4-digit decimals using the 4-digit BCD converter. Then they're sent to the 7-segment decoder, which displays the score. When the countdown reaches 0, the game end module lights the LEDs of the winning player one by one, and if there's a draw, the LED colors for both players are lit one by one. And then now my friends are gonna talk about the hardware.
My name is Islam, and I will talk about the hardware part. We used for this project a big breadboard to put the components on. We used 9 buttons, 9 red LEDs, and 9 green LEDs for each player. And we used 2 4 to 16 line decoders to assign random LEDs from the inputs, and 2 7-segment decoders to assign the 7 segment from the code of the PC. And I guess that's it. My partner will talk about the connection.
Hey, hello everyone. My name is Mohammed Ibrahim, and I'll talk about how everything is integrated in our project. So first off, we'll start with the 4 to 16 decoders, which were used to light the LEDs in random positions. The decoders each has 4 selection lines connected to the FPGA, and the outputs are connected to the LEDs. So they choose a random position and then assign it to one of the LEDs on the board. Next up is the two 7-segment displays. The 7-segment displays were used to display the game time, which was 60 seconds. Now, the two 7-segment decoders were used to minimize the number of selections needed to display the numbers on the 7 segments. So basically, normally we would need 14 selection lines to display the numbers on the two 7 segments, but now we just used 8 selections only. Now for the buttons, the feedback, basically we connected the wires to the FPGA, so when they are clicked, they set a positive signal to the FPGA, and the score is calculated. That's about it.